Today in calculus, we're going to once again study under differentiation, and we're going to take a look at the quotient rule. Now, the quotient rule is going to be derived from the product rule. Now, you could always just use the product rule because of that, but it's actually much easier in certain instances when we memorize the quotient rule. It will save you a few steps along the way, and this would be an example why. So let's just say if I wanted to derive this right here, f of x over g of x, well, this is the same as f of x times g of x, all of that's to the negative first power. So if I were to use the product rule, well, that says the derivative of the first times the second plus the first times now the derivative of the second. So the derivative, this is going to be the chain rule. So the derivative of the outside, so that's going to be negative 1 g of x to the negative 2 times, now the derivative of the inside would be g prime x. Now this looks really ugly, so we got to clean this up. So in this instance here, this will be f prime x over g of x, and then that minus here, so minus plus, so that would be minus. Now this is to the second power, so that's going to go in the denominator. So, and then I have f of x and g of x on top, so f of x times g prime x, and this is going to be over g of x squared. And so now to combine these together, find the common denominator. So this needs a g of x over g of x, because I have two of them in the other. So now I get f of x g of x minus f of x times g prime of x all over g of x squared. So that's f prime x g of x minus f of x times g prime x over g of x squared. And this right here, this is the quotient rule. And so you'll actually find out that that's a little bit easier to memorize. So the derivative in that scenario, right, we just derived it there. A way to memorize it is if it looks like in this form here. This is high, this is low, and so low d high, the derivative of high, minus high d low, denominator squared below. So it kind of helps us memorize that. So low d high minus high d low, denominator squared below. So in this instance here, if I wanted to find the derivative of this, so low d high minus high d low, this is going to be the chain rule, so 5 cosine of 5t. So low d high minus high d low, denominator squared below. Now this is an algebraic mess, and we're going to have to kind of go through and clean it up just a little bit. Notice there's a cosine of 5t in common, so I can factor that out. So I'm going to be left with this 5, and this is going to multiply together. So I'm going to get 9t squared minus 15t cubed. That's going to be all over cosine of 5t squared. Those will cancel out, so my final answer would be that. Let's look at another one. So low d high, so that's the derivative of the top, minus high d low, denominator squared below. Now, if there was a way for us to simplify this algebraically, we could, but even on the AP test, that is an acceptable response for if you were to ask to take the derivative. That is a perfect handwritten response there. You applied the derivative, you're done. Now with tangent x, this is going to be kind of like a proof. Why is it secant squared? Well, because I could rewrite this as sine of x over cosine x. And so low d high minus high derivative of the bottom, denominator squared below. Well, this is cosine squared x. Negative negative is a positive, which is, that's 1 over cosine squared x, which is secant squared x. What? Isn't that cool? That's why tangent x is secant squared x when you take the derivative of it. So what is the quotient rule? Boom. That's the new rule that we applied to differentiation. It's something that we need to know. It's something you need to memorize. And so to help us memorize it, low d high, that's referring to the derivative. Low is the denominator, high is the numerator. So low d high minus high d low, denominator squared below. And that's the interpretation of that statement right there. Now this does conclude our lesson. If you have any other questions, please leave them in the comments.